Okay, now we will see how the block rotor test can be performed on this single phase induction motor. So the circuit diagram for performing the block rotor test on single phase induction motor is this one. So the only change when we see this diagram with respect to the no load test is that in the no load test we have connected here one link between M1 and U1. Okay. So in the block rotor test we have to remove this link between M1 and U1. Now once we remove this link between M1 and U1, what will happen? The starting winding will get disconnected from the circuit. And once starting winding get disconnected from the circuit along with capacitor and centrifugal switch, the motor automatically driven in the blocking stage, so that automatically motor get blocked. So there is no need to hold the rotor of the motor manually by hand during the block rotor test. Okay, so the connections, like we can take supply again from the dimmer. Initially it is given to ammeter, then second terminal of ammeter will go to wattmeter, and wattmeter M and C will get shorted, and from L it will go to M1, that is main winding of the induction motor, and from M2, that is main winding second terminal of induction motor, it will go back to supply. Okay, and voltmeter as usual is to be connected across the supply, and this pressure coil terminal of V will go again back to supply. So these are the connections. Okay, now see the setup. Here it is the setup. Now in this setup the connections are similar to what we have seen in the no load test. Only see the change, whatever this link is there, this is the link between U1 and M1. So I will remove this link. Okay, now once I remove this link, what will happen? This starting winding will get disconnected from the circuit, and only main winding M1 M2 to, that is, we are energizing by giving this single phase supply through the dimmer. Okay, and the second adjustment is that the no load, since the rated current of this motor is 6.6 ampere, so I can connect this ammeter now to 10 ampere. Earlier during the no load test I have connected it to 5 ampere. Now I have changed it to 10 ampere since the current is 6.6 ampere. Now the procedure. Now the procedure is, we have to give a reduced voltage to the motor such that the current that is drawn by the motor is rated one. That is, we have to give a reduced voltage till motor draws rated current of 6.6 ampere, and we have to note down the values of VSC, ISC, which is 6.6 ampere, and WSC. Of course the speed of the motor will be 0 because the motor is in the block rotor condition, therefore the speed will be obviously 0. Okay, so now I will switch on the supply. Supply is switched on. Now I will apply reduced voltage to the motor till motor takes the rated current. So I will slowly increase the voltage. See, the current is slowly increasing now. Motor is already in the block stage, so it will not rotate. Okay, so gradually I am increasing the voltage. At present I have applied here voltage of say nearly 40 volts, 45 volts. Now we have to observe the current should not exceed the rated value. Now rated value of the current is 6.6, so we have to apply the voltage till the current drawn will be 6.6. At present now it is 6 ampere, it is now 6 ampere, so it is increasing 6 point, now it is 6.4, and this is now 6.6. okay, so this is ISC 6.6 exactly. Now corresponding to 6.6 ampere, how much is the short circuit voltage? It is 80 volts. So you can see it is 80 volts is the VSC, and WSC will be 50, 60, 70, 80, 85 volts, almost 85 volts, and the speed is 0. See, you can see motor is not running, it is in a block stage, right? So we can note down these particular readings. VSC was 80 volts, ISC was the rated current which was 6.6 ampere, and WSC was 85 watts into its multimeter was 4, and speed was 0. Okay, so this is how we can perform the no load and block rotor test on single phase induction motor. Obviously, the basic purpose of doing this particular experiment I have forgotten to tell. The purpose is we want to find out the equivalent circuit parameters of the single phase induction motor, and once we know the equivalent circuit parameters of the single phase induction motor, we can able to predict the performance of the single phase induction motor in terms of calculating its slip, efficiency, output power, torque, etc. And thereafter, of course, we can draw the equivalent circuit of the single phase induction motor also. So that is the purpose of performing this particular experiment. Thank you.